Hey everyone! Last year I challenged you to build your own chain reaction machines at home. Now I'm back with our Think Hub partners from across Northern Ontario, and we have a new challenge for you. Musical instruments.
When we think of science, maybe we think of labs, beakers, hard work, and research. But science can also be fun. Science is part of almost everything fun we do in our daily lives, even art and music. We're going to show you some of the instruments you might create at home while you can't come out to our centers.
Have you ever wondered how the science of sound works, or why certain instruments sound the way that they do? Well then, let's take a look at what is sound. Sound is really a form of energy. At a microscopic level, sounds are produced and travel through the vibrations of tiny little particles. Everything around us is made of these particles, including the air that we breathe. And when these particles vibrate, they give us sound. When the particles vibrate faster, their sound has a higher pitch, while slower vibrations create sounds with a lower pitch. Let's see what this means for different musical instruments. String instruments, like guitars, harps, or violins, create different pitched sounds by using different lengths of strings, or by stretching their strings to different tensions. Percussion instruments, like drums and xylophones, make sounds by being struck. Many of these instruments have hollow bodies that make their sound a lot louder by amplifying the vibrations. Different shapes and sizes of percussion instruments will produce different sounds because they vibrate differently. Wind instruments like flutes, horns, or even a harmonica work in a very similar way. When we blow through a wind instrument, the air is split by the many different holes and openings, which causes the particles to vibrate and create different sounds. For example, covering many holes on the recorder will cause the sound to be a lot lower, since the particles have to vibrate for a longer distance and will therefore vibrate faster.
Let's try and put these principles to the test by creating our own instruments. We used a paper towel roll, poked some holes in it, put some toothpicks, closed the ends, and filled it with beads to make a rain stick. And the slower you do it, the more it sounds like rain.
Here in Thunder Bay, we decided to make some maracas. We took empty plastic Easter eggs, cracked them open, and filled them about 1/3 to 1/2 full with 2 different kinds of things. We used crunchy uncooked rice and small hard pasta noodles. Closed them up, used some masking tape to seal up. We opted to keep one just simple and decorated with some sequins and glue. The other, we used 2 plastic spoons to brace the egg, more tape to keep everything nice and tight, and then we still decorated. Different sounds.
Now I have in front of me 6 glass bottles, each one with a different level of water inside. If I blow some air across the top of this bottle, the sound has a high pitch. This is caused because the bottle has a high volume of water, which prevents the vibration from being very long. Now on the other hand, if I take this bottle and blow, the sound has a much lower pitch since there's less water in the bottle, and this causes the vibration to be longer. Now I have filled each one of these bottles with a different level of water, each one with a little bit less water than the last, to create a scale.
Hey, we're here in our Science North Think Hub /Makerspace, and today we have a tambourine.
The tambourine is a handheld drum, 30 centimeters in diameter, and when you shake it, it makes a great splashing noise.
So here's what you'll need to make your tambourine: a foil pie plate, paper clips, plastic laces, foam shapes, tape, and scissors.
When you put it all together, you can decorate it any way you like, and then you'll have yourself a lovely tambourine.
This musical instrument was inspired by the glockenspiel. When you hit the side of the jar, it creates a vibration, and the vibration is the sound that you hear. The more water in the jar, the slower the vibration, the lower the pitch. Let's listen. If you would like to try this at home, you will need some glass jars out of the recycling, a spoon, I used a 1/2 cup measure, some water, and the food coloring is completely optional. To start, line up your jars. I left the first one empty. Then I added 1/2 cup water to the first jar, 2 1/2 cups of water to the next jar, and continued on until all my jars were full. Good luck and have fun.
This is just one of the many aspects of science that can be explored with the Think Hubs. We would love to see your creations, so share them in the comments or by tagging #ThinkHubs, ThinkHubs.